All right, Ash, so I'll go through this again here for you if you need to see it. Just erase a lot of this stuff here. So, two main strategies for this particular graph, or for this particular system, I should say. Okay, option one is you can just graph it, okay, and that's what I showed you guys earlier, okay? So you just literally just type in y equals 2x cubed minus 5x squared into your graphing calculator, and you type in y equals negative 1x minus 2 into your graphing calculator, and then you find the point of intersection. Let's see, do I have my emulator up? I do not. Let me get it up here real quick. Here it is. Okay, so I don't think you're gonna have to like turn your head for this because I don't think it's gonna record right. So anyway, so you can see here in the y equals, I have typed in both of those equations, right? And so you can graph them. You can see 3 points of intersection there where the two graphs intersect, right? And you just press the second button and then trace, and you go down to intersect. And you just put your cursor moving left or right, put your cursor close to where the point of intersection is. So there's one, so just hit enter 3 times, and there's a point of intersection. So there's one of our answers. And you can go through and do the rest of that for all those other points, okay? But if you really want to know how to do it without a graphing calculator, then I'll go back to the notes here. Okay, so that was the graphing calculator method. You already saw the answers for that. To do this without a graphing calculator, we'll use like that substitution method that I showed. Okay, and the reason is because both of these equations are equal to y. Since they're both equal to y, then where I have like y equals 2x to the third minus 5x squared, this y right here is the same as this y right here. It's all a system. So this negative 1x minus 2 can replace that y in the equation. Okay, just like so. And now to solve a polynomial equation, typically we want it to be equal to 0, right? So we can try and factor and stuff like that. So I'm going to add the 1x over here. I'll add the 2 over to both sides so that way they, we get equal to 0. And so we'll have 0 equals 2x to the third minus 5x squared plus 1x plus 2. Now you said in your email that you couldn't get this thing to factor, and you're right, it doesn't factor. It does not factor. So how do we solve a polynomial that doesn't factor? Well, that's where we go to our guess and check method that we talked about. I think it was just before break, or maybe it was during this break. I kind of forget when we taught it for this class. But anyway, it's where you identify your constant term there of 2, and then your lead coefficient there of 2 as well. Okay, and we do the factors of 2, which is plus or minus 1 and plus or minus 2, and we do the factors of, well, the other 2. So we typically call that 2 there the constant term p, and the lead coefficient is q. So this is our p, this is our q right there. And so again, it's plus or minus 1, plus or minus 2. So to then, how do we use this information? Well, so these numbers provide us with the candidates for rational zeros. So this gives us a list of possible rational zeros to check in our polynomial to help us factor this polynomial. Okay, and really all we need to do is figure out one zero that works. Since this thing is a cubic, right? Since it's a cubic, then if we find one zero that works, that will reduce it down to a quadratic, and then we can factor a quadratic, or at least use quadratic formula if we need to. Okay, so let's take a look then at this graph and see. So let's see here. And again, this is where you're going to get, so sorry, I didn't get to finish writing these possible rational. So the possible rational zeros will be 1 over 1 and 2 over 1, okay, because you put the p over the q like that. So we'll have plus or minus 1 and plus or minus 2. And then we'll also do 1 over 2 and 2 over 2. So 1 over 2 creates a new 0 of plus or minus 1/2. And then 2 over 2, it's, well, 2 over 2 is the same as 1, which we already have right here, so we don't need to write 2 over 2. Okay, and so then we just guess and check using that synthetic division to help us determine, what is which one of these zeros works, if any of them work. Okay, and so, you know, we can just guess, for example, like let's guess that positive 1 works. And so I'll put the 1 in, and then I'll put in my, you know, coefficients here from my polynomial. And so, oops, and so 2, -5, 1, and 2, and then we'll just do this in division and see if it works, right? So drop that 2 down. 2 times 1 is 2, -5 and 2 is -3, and -3 and 1 is -3, 1 -3 is -2, -2 times 1 is -2, and 0, and aha, we found one that works. So 1 is the x-coordinate of one of our zeros. And that leaves us with this answer right here, which, remember, we interpret that as 2x squared minus 3x minus 2. We know it's x squared because our original polynomial was a cubic, and when you divide something out of your polynomial, you reduce the degree by 1, so the cube becomes a square. Okay, so then we check to see if this quadratic here factors, right? Because we know how to factor quadratics, right? If a quadratic factors, we can do it. And if it doesn't factor, then we can go to the quadratic formula or something like that. So in this point, you can use AC method if you want to, or you can use guess and check. I'm going to use guess and check because, you know, that's just a pretty easy way to do it here, I think. We can figure that out. So we need these two numbers here to multiply to make -2. But then this number we multiply with 2x, right? And this number here will multiply with this x right here. And so whatever number we put in here is going to double with that 2x right there. So, and we need to multiply to -2. Don't forget that as well. So let's see here. I think if I put a -2 here and a +1 in there, that's going to work, right? We'll have 2x times x, which is 2x squared. We'll have and we'll have 1 times x, which is 1x, and 2x times -2, which is -4. -4 and 1 makes that -3 we're looking for there. Okay, and then 1 times -2 will give us -2. So we factored correctly, right? It's equal to 0, remember, because from our original equation there. Okay, and so then we get, when I solve, I get 2x plus 1 equals 0, I get x minus 2 equals 0, and so x equals -1/2, and x equals 2. Now, there are our three answers. X equals 1, x equals -1/2, and x equals 2. But here's the issue, we need to find the y coordinates too. And that you get by just plugging them back into one of your original equations. You can either plug it into the cubic there or to this linear equation, whichever one you want, and get the matching y coordinate. And you do that for all three of these x values there. Okay, and I don't need to do that. I think you can figure that out. Okay, so yeah, hopefully that helped.